Hey everyone, let's talk about one of the first things that trips up pretty much every new Python programmer. Why on earth do we start counting at 0? It just feels weird, right? Well, it turns out there's a really cool reason behind it, and that's what we're going to dive into.
Seriously, if you've been confused by this, you are in very good company. It's probably one of the most common questions out there. So let's just tackle it head on and clear things up for good. Okay, so let me ask you a simple question. You've got a list of things, say a grocery list. What number do you give the first item? I mean, it's 1, right? Of course it is. That's how we count in the real world. But, you guessed it, Python plays by a different set of rules. And that rule has a name. It's called zero-based indexing. Now, it might sound a little technical, but trust me, once this clicks for you, a whole lot of other programming concepts are going to make way more sense. So what is it exactly? Well, zero-based indexing is just a fancy way of saying that the very first thing in a list, or any sequence, gets the number 0. Not 1, 0.
And really, this is the main takeaway. If you remember nothing else, remember this. The first element is always at position 0. That means the second element is at position 1. The third is at 2. You see the pattern. It's just a little one-off shift, but it's a super important one.
Okay, but that still leaves the big question unanswered. Why? Why do it this way at all when it feels so counterintuitive? Well, there's actually a really elegant and logical reason, and it's not just to confuse beginners, I promise.
And the key to unlocking this whole mystery comes down to one simple word: offset. See, in Python, an index isn't really about counting things 1, 2, 3. It's about how far away an item is from the very beginning of the list.
This table lays it out perfectly. Think of it like you're standing at the start of a path. The very first item is right at your feet. How many steps do you need to take to get to it? 0 steps. You're already there. So its index, its offset, is 0. Now, to get to the second item, you take 1 step forward. So its index is 1. To get to the third, you take 2 steps. Its index is 2. See how that works? It's not counting items, it's counting steps from the start.
All right, enough theory. Let's see this in action with some actual code. This is where the rubber meets the road. So here we have a simple list of fruits. If we want to grab apple, we ask for fruits 0. If we want banana, that's fruits 1. Those square brackets are basically us telling Python, hey, go to this exact spot, this offset, and tell me what's there. And it's not just about pulling out values to look at. You can actually use these items in calculations, which is where things get really powerful. For instance, let's say we have this list of numbers. If we tell Python to calculate numbers of 0 plus numbers of 1, what's it going to do? It'll go to index 0, grab the 10, then go to index 1, grab the 20, add them together, and voila, you get 30. It's a super direct way to access and work with your data.
Okay, so this brings up another classic programming problem. What if your list has like 1,000 items in it, and you just want to get the very last one? Are you supposed to figure out that its index is 999? That seems annoying.
Well, Python has this awesome, super clever solution called negative indexing. You can count from the start with positive numbers, like we've been doing, or you can count from the end using negative numbers. So -1 is always the last item, no matter how long the list is. -2 is the second to last. How cool is that? It's an amazing shortcut. Okay, so that was a quick crash course in one of Python's biggest gotchas. Let's just quickly recap the main points to make sure they stick. First off, Python uses zero-based indexing. That just means the first item is always at index 0. And remember, the why. An index is really an offset, or the number of steps from the beginning. This whole system is what lets us directly access any value we want. And finally, don't forget about that super useful trick. Negative indexes lets you count backward from the end. So when you boil it all down, this whole counting from 0 thing isn't just some random rule made to trip us up. It's actually based on this really clean, logical idea of offsets. It's a great reminder that a lot of things in programming that seem weird at first have a kind of hidden elegance to them. Which leaves me with a final question for you. Now that you know the logic behind this one, what other programming rules have you come across that seem strange but might just have a cool reason hiding underneath? Thanks so much for tuning in.